Hello friends, welcome to Susan and John MathTube. This is lesson number 2 in beta gamma functions, and as always the most important question and the 5 important points. Okay, let's start. So in the last video you learned what is the beta integral and the gamma integral. And always remember, m and n in general are kept positive. And then we learned the connection between the beta integral and the gamma integral. And we also learned the reduction formula for gamma integral. So the basic plan is, whenever we have something in beta, we just convert it into gamma and evaluate gamma using the reduction formula. And the most important value you must remember is gamma 1 by 2, that is root pi. Anyway, let's start. But as always, I will strongly recommend, if you did not watch lesson number 1, pause this video right now and go for lesson number 1. So please write one question. Evaluate the integral 0 to a x square times a square minus x square the whole power 3 by 2 dx. Now look at this. This integral looks really complicated. But I promised you one thing in the last lesson itself. We learned so many different techniques so that we will be able to escape whenever you have a complicated function to integrate. Anyway, look at this. Suppose you have 1 minus x square inside a square root or a to the whole power 5 by 2 or 3 by 2. Basically anything related to 1 by 2, that means a square root. The substitution is x is equal to a sin theta or cos theta, because 1 minus sin square theta will be cos square theta, and you will be able to escape from the square root. Suppose you have 1 minus x. Can you tell me the best substitute? Yeah, x is equal to sin square theta. Because if you have something like root under 1 minus x, of course sin square theta will be able to help you. Because 1 minus sin square theta is cos square theta, and root under cos square theta becomes cos theta. Now suppose you have root under a minus x. Now come on, it's time to think. I already gave you the hint. It will be related to sine. Now what can we do here? Okay, I'm going to put x is equal to a sin square theta. Do you know why? If I do that, it will become a minus a sin square theta. Then a will come common, and 1 minus sin square theta is nothing but cos square theta, and you end up with root a cos theta. So this is the general pattern. And one more thing, if you have sin theta, then definitely the substitute cos theta will also work. So you can try the same thing with cos. And one important thing, because you might have learned this in plus 1 plus 2. Suppose you have 1 minus x and 1 plus x together. Suppose you have 1 minus x square and 1 plus x square together in a problem. Then most probably this sin theta will not help you, because by just looking at this 1 minus x, don't put sin theta. And remember, I am not giving any guarantee for these substitutions. I am telling you these substitutions may work. So remember, there is no 100% guarantee for this method, but still you can try. And if root under 1 minus x and 1 plus x comes together, or in this pattern or this pattern, the best method will be to remember the formula 1 minus cos theta is 2 sin square theta by 2, and 1 plus cos theta is 2 cos square theta divided by 2. Because you can substitute x equal to cos theta and it works in the numerator as well as the denominator. Anyway, it is time to start with our question. So what I'm planning to do is, exactly, I'm going to put x is equal to a sine theta. Now the golden rule, whenever you make a substitution in a definite integral, you have to do two things. Point number one, you find the differential. That will be a cos theta d theta. And the second thing is to change the limit. Look at this. The variable of integration is x. So this limit belongs to x. So what we do here is we write sine theta is equal to x by a. And that gives me theta is equal to sine inverse x by a. So if x is equal to 0, theta will be sine inverse 0 by a, that is 0. If x is equal to the upper limit, then theta will be sine inverse a by a. What is a by a? 1. Sine inverse 1 is 90 degree. So what we do is we plug in all these things and we get theta is equal to 0 to pi by 2 x square. What can I do instead of this x? A sine theta. So we get a square sine square theta. In bracket, what will be that? A square minus a square sine square theta whole power 3 by 2, and dx is right here. I think I have to erase that, I don't have space. So what is that dx? A cos theta d theta. Now time to simplify. Look at this. Some of you might be very good in laws of indices. They will have no problem with this topic. But if you feel that you need this, please write a power m, the whole power n is a power m into n. A power m times a power n is a power m plus n. And ab, the whole power n is a power n b power n. And square root means to the power 1 by 2, cube root means to the power 1 by 3, and 1 by a power n is nothing but a power minus n. Okay, now let's continue. So look at this. There is an a square here and there is a here, and what happens here is a square will come common and you get 1 minus sine square theta. And remember, all this happens to the power 3 by 2. Now what is 1 minus sine square theta? It's cos square theta. So this becomes a square cos square theta, the whole power 3 by 2 according to this formula. Look at this. A, B, two different characters, the same power. It can be split. So look at this. A, B, two different quantities. The power is same, but we can split it. So we get a square the whole power 3 by 2, cos square theta the whole power 3 by 2. So basically we end up with a cube cos cube theta. So I'm going to skip a lot of steps. I is equal to integral 0 to pi by 2, a square sine square theta, and then I showed you the simplification. I'm warning you, I'm skipping a lot of steps. And of course, dx, the value is, what is dx? A cos theta d theta. I hope you understood this. I'll show you that steps once more. This is the same, and this one I simplified here, and this is a cos theta d theta. And the most important part, theta varies from 0 to pi by 2. Now combine this constant, constant, constant. So we get a to the power 2 plus 3 plus 1. That is I is equal to a to the power 6 integral theta is equal to 0 to pi by 2 sine to the power 2 theta and cos to the power 4 theta d theta. And that is equal to a to the power 6 1 by 2 beta 2 plus 1 3 4 plus 1 5 Yeah, that's it. So 8 to the power 6, 1 by 2, gamma 3 by 2, gamma 5 by 2 by 3 plus 5, 8, 8 by 2, gamma 4. And that gives me, I think I should leave this as a homework. Anyway, I'll complete it. That will be 1 by 2 root pi, 3 by 2, 1 by 2 root pi by 3 factorial. And one more thing, if you're finding this part difficult, that means you have not watched lesson number 1. Okay, so you can simplify, you get pi 8 to the power 6 by 32. Let's move on to the next question. I is equal to integral 0 to 1 x to the power 6 the whole divided by root under 1 minus x square dx. As I told you before, I can see root under 1 minus x square. So the best substitute will be x is equal to sine theta or cos theta, to be honest. And whenever you make a substitution in a definite integral, two things: the differential, and second thing, the limits, because this limit belongs to x. The variable of the original integral is x, so this limit belongs to x. Okay, come on, now tell me what is theta is equal to. Theta is sine inverse x. And if x equal to 0, theta will be sine inverse 0, that is 0. If x equal to the upper limit, that is 1, theta will be sine inverse 1, that is pi by 2. So we end up with I equal to integral theta varies from 0 to pi by 2 x power 6. Who is our x? Sine theta. So sine to the power 6 theta by root under 1 minus sine square theta. I already know what's going to happen. This will become cos square theta, the root will be cos theta, and dx, where is my dx? Yeah, here, cos theta d theta. And you can simplify this because these two are going to get cancelled. Okay, now look at this. In case they ask use beta gamma function in the question, don't use the shortcut from reduction formula. We know there's an awesome shortcut from the reduction formula, that is 6, 5, 4, 3, 2, 1. And since the power is even, we put pi by 2. So we know the answer, and as students you'll be tempted to use this, but wait a minute. If in the question it is mentioned use beta gamma integrals or beta gamma function, don't do this shortcut. But if nothing is mentioned, it's your will. Okay, so anyway, let's assume beta gamma function was asked. So it write 1 by 2 beta 6 plus 1 7 by 2 comma 1 by 2, and that will be 1 by 2 gamma 7 by 2 gamma 1 by 2 the whole divided by 7 plus 1 8 8 by 2 4 gamma 4, and that is 1 by 2, then 5 by 2 3 by 2 1 by 2 root pi the whole divided by 3 factorial. Find the answer and you will get 5 pi by 32. Okay, now let's move on to one more question, similar question. Look at this. If you want to be perfect with any topic, you should practice a lot. And if you practice a lot, when you write the exam, you will find really comfortable and confident. Okay, now tell me please. It's a very easy question, and I can see root under a. Did you write the question? Yeah. So I can see root under a square minus x square. So what will be the substitute? Tell me please. Yeah. X is equal to a sine theta. If you are in a mood to do some experiments, then you can try with a cos theta, and comment below whether you got the same answer or not. What are the two things? Okay, the differential. So dx equal to a cos theta d theta. And then tell me what is sine theta is equal to, because sine theta means x by a. So theta will be sine inverse x by a. And here the lower limit is 0, upper limit is a. So I am going to write like this. If x is equal to 0, theta will be sine inverse 0, that is 0. If x is equal to a, theta will be sine inverse a by a. A by is going to give me 1, and that is theta is equal to 90 degree. So what happens to the integral? The limit will change to theta because that is a new substitute, and our x becomes a to the power 4 sine to the power 4 theta. The whole divided by, you already know what will happen here, a square minus a square sine square theta. Even if you know what is going to happen, in the exam paper, don't skip critical steps. Because your exam paper or the answer paper is a presentation. And when you do presentation, you don't skip, normally you don't skip steps. It's not a good idea to skip steps in your exam. Anyway, dx becomes a cos theta d theta. So you want me to do this, or shall I cancel it directly? What will happen here? A square comes common and you get 1 minus sine square theta. And 1 minus sine square theta is cos square theta. And when you take square root, it becomes a cos theta. So this and this will get cancelled. So a power 4 goes outside. And we are left with theta is equal to 0 to pi by 2 sine to the power 4 theta d theta. I am warning you, don't use the shortcut. The shortcut means reduction formula, because in the question it might be mentioned using beta gamma find the integral, evaluate the integral. And if you don't use beta gamma for such a question, that is a mathematical crime. And of course, they might cut your answer. But if nothing is mentioned, it's your wish. But it is good to mention by using reduction formula. 4 means 4 plus 1, 5, 5 by 2 and 1 by 2. And that will be a to the power 4 by 2, gamma 5 by 2, gamma 1 by 2 by gamma 6 by 2. And that will be a to the power 4 by 2, 3 by 2, 1 by 2, root pi by 2 factorial. So 2 factorial is 2 into 1, 2. So 16 comes, the answer is 3 pi a to the power 4 by 16. Okay, now one more question of the same type, and that will be the last question I am going to work out in the screen for you. So please write, evaluate the integral 0 to a x cube into a square minus x square the whole power 5 by 2 dx. Now look at this. As first year engineering students, I am sure that some of you are going to skip this question. Don't do that. Don't do that. And if you do that, you will never be good in the subject. You may know how to work out the problems, but working out the problems is very, very, very important so that you are confident for the exam. So tell me what to do here. You are stuck with something to the power 1 by 2. Basically 5 by 2 means 1 by 2 the whole power 5. Yeah, so the substitute is, we put x is equal to a sine theta. And as always, the two things, dx equal to a cos theta d theta. And from here, I get sine theta is equal to x by a, and that gives me theta is equal to sine inverse x by a. So if x equal to 0, theta equal to 0, x equal to a, theta equal to pi by 2. We did a lot of problems, so we know that. Now let's substitute. I equal to integral 0 to pi by 2 x. X means a sine theta. So a cube sine cube theta. And this whole thing, you have to do that drama because in the exam there will be only one question, and that drama part is the presentation, and that presentation is very important. Minus a square sine square theta, the whole power 5 by 2, and our dx is here, a cos theta d theta, and that gives me a cube and sine cube theta. Now tell me what happens here. A square will come common, 1 minus sine square theta will be cos square theta. So we get a square cos square theta, the whole power 5 by 2, a cos theta d theta. Now I am going to skip a lot of steps. So tell me, this will be a cube, this will be a power 5, and this is a. So 3 plus 5, 8, 8 plus 1, 9. So in the next line, I am going to write a power 9 outside, and theta varies from 0 to pi by 2. Now look at this, sine to the power 3 theta, cos to the power 5, 5 plus 1, 6. So I am going to write sine cube theta, cos to the power 6 theta d theta. And that is a power 9, 1 by 2 beta, 3 plus 1, 4 by 2, 6 plus 1, 7 by 2. And that is a power 9 by 2, 4 by 2 is 2, isn't it? So gamma 2, gamma 7 by 2 by gamma 2 plus 7 by 2, that is gamma 11 by 2. And that's it. Now you can work out the problem by yourself. And the answer is 2 by 63, a to the power 9. Okay, now I'm going to wind up this video right now. In the next video, I'll work out two very important questions. Important in the sense, I checked your past question papers. I checked a few past year question papers, and I found those two questions popping up again and again and again. So my friends, I'll be back soon with those important questions in beta gamma functions. And as always, if you like the video, please share and subscribe. So we'll meet again very soon. So till then, my friends, bye.